If you have ever looked at the back of an office router, you have seen a chaotic wall of ports, blinking lights, and a tangle of colored wires. In networking, these connection points are known as interfaces. They are the specific entry and exit points that allow data to move between devices or out to the internet. Some of these interfaces are physical. This fiber optic setup is a hardware-based transmission line, using light signals to move massive amounts of data through glass strands. Other interfaces exist only in software. These virtual doors allow for internal testing through loopbacks or secure remote connections via VPN tunnels, providing flexibility that hardware alone cannot match. The choice of interface for any given connection depends on the required speed, the level of security needed, and the physical environment. Managing a network requires identifying which specific physical or virtual pathway is built for the task at hand. To see how these interfaces work in tandem, consider a layout with 4 computers, 2 networking switches, and 1 central router connected to the outside world. The first leg of the journey is the physical link from the computer to the switch. Today, the standard is Gigabit Ethernet, which uses the IEEE 802.3ab specification to move data at 1 billion bits per second. That is 10 times the capacity of its predecessor, Fast Ethernet. While Fast Ethernet capped out at 100 megabits per second, Gigabit allows for the high-volume traffic we expect from modern networks. Fast Ethernet was a vital bridge during the late 1990s, but it lacks the bandwidth required for current cloud computing and high-definition streaming demands. These connections usually rely on copper Cat5e or Cat6 cables. In this Cisco switch, the active green cables show a star topology in action, where every device has its own dedicated path to the central hardware. This physical infrastructure sets the absolute hard speed limit for the very first step of any data transmission. Speed is only half the battle. If PC1 sends a file to PC2, the network has to ensure that data is delivered to the correct recipient without shouting it to every other computer in the building. This process is known as Layer 2 bridging. When the packet hits the switch, the hardware registers the unique physical MAC address of the destination device and forwards the data exclusively to that specific port. But if PC1 needs to send a file to PC3, it has to cross over to a different switch. To do that, the packet must travel up to the central router. The router uses its own virtual interfaces to manage different local subnets. By reading the IP address, it directs the packet down through switch 2 to find PC3 on its separate network segment. While switches act as local traffic controllers for physical addresses, routers function as the major intersections that move data between distinct neighborhoods. For the final leg of the journey, imagine PC3 requests data from a website. Now, the packet must leave the local office and enter the Wide Area Network, or WAN. To connect to outside telecom providers, the router might use a serial interface. This beige DB9 connector is a specialized gateway for long-distance communication. Serial transmission works by sending data sequentially, 1 bit at a time, over a single channel. While this is much slower than local Gigabit Ethernet, its simplicity makes it highly reliable for point-to-point lease lines and industrial automation systems that span great distances. The router's role is to translate that high-speed local traffic into a format designed for the specialized architecture of the global internet. From the initial click at a Gigabit interface to the Layer 2 bridge and the final route to the WAN, every step of this journey is handled by a specific connection point. A high-performance IT environment is built by matching the right physical and virtual interfaces to the unique requirements of the data they carry. The array of ports on the back of a router represents a structured system of gateways, each maintaining the vital link between a local desk and the rest of the world.